So hello everyone, very good evening. So here we are going to discuss about radiation heat exchange between two black surfaces. Okay, today we are going to cover radiation heat exchange between two black surfaces, and these black surfaces will be like we have seen in the previous topic. And I hope everyone is joining. Hello Anshul, Anshul, how are you, beta? So you can ask your doubt classes related to the heat and mass transfer topic radiation in this particular video lecture, and we have also covered previously we have covered shape factor and various examples. So I'm gonna solve maximum number of questions in this lecture also related to the shape factor and reflection also, and also we will be solving like maximum number of questions between two black surfaces, my dear students. So everybody is joining now. Join continuously, and message me in the comment box so that we can discuss your doubts, my dear students. So that we can discuss your doubts. Okay, now everyone, Anshul Panjal, Anshul, you can comment me here. Hello, beta. Very good evening. How are you? Hello, beta. Very good evening. How are you? So let us start the class, and I want to clear that if someone is having any doubt related to radiation or any topic in the radiation or heat and mass transfer, he can visit the Ekeeda GATE ESC portal on the YouTube and all can study all the topics, and you will enjoy the topics. I'm telling you, you will enjoy all the material available there. And also we are solving all the GATE questions on the YouTube lecture or live doubt classes, so you can ask your doubts related to the GATE questions, related to anything, any topic in this particular video lecture. Hi, Ritik Kapoor. Hi. So let us see. Now we are going to do everything like let us see. Let us see the GATE questions, my dear students. Ritik, you can ask your comment. You can ask your comment. There is okay. So let us solve your doubts, and also we are going to solve each and every question. So let us see this question. So my dear students, let us see this question. So I have given you this question. You can see there on the screen. So am I completely audible and screen is available? Ritik Kapoor, thank you so much. Thank you so much. Thank you so much for such a nice comment. I'm enjoying that comment. Okay. So Ansul Panjal, let us see this question, my dear students. And simple questions they are asking in the GATE. Okay. So let us see. So here what they have given, the following figure was generated from experimental data relating to spectral black body emissive power. Okay. So that is the power of the black body, emissive power of the black body, and they have given the wavelength for the three temperatures, T1, T2, and T3. So this is the graph in between the minimum wavelength and your emissive power of the black body. So you have to tell that the conclusion is that the measurements are. So he is asking the conclusion of that particular graph. So number A is saying that correct because the maxima is EB lambda, show that correct trend. Okay. So what is saying that EB lambda trend, these graphs are showing the correct trend. Number B, correct because Planck's law is satisfied. So they are asking if Planck law is satisfied, like which law will satisfy this particular graph, they are asking. So let us see the options. Correct because the maxima is in EB lambda, show that correct trend. Correct because Planck's law is satisfied. Correct, wrong because the Stephen Boltzmann law is not satisfied. Wrong because Wayne's displacement law is not satisfied. So which one is the answer? Tell me Ritik and Kapoor. Anshul, you can tell me. So which one is the correct answer for this? So you have seen your Wayne's displacement law, और Wayne's displacement law में बेटा क्या देखा था आपने कि जब भी आपका मिनिमम वेवलेंथ होता है, तो जो मिनिमम वेवलेंथ पे आपका जैसे ही टेम्परेचर आपका बढ़ता चला जाता है, व्हाट हैपेंस टू द ग्राफ, दैट शिफ्ट टुवर्ड द लेफ्ट, दैट शिफ्ट टुवर्ड्स द लेफ्ट. लेकिन यहाँ पे कहाँ पे शिफ्ट हो रहा है बेटा? इट इज शिफ्टिंग टुवर्ड्स द राइट. So this is the graph of your what? Wayne's displacement law, but that is the wrong graph. Okay, my dear students, that is the wrong graph. So let us see. So what will happen? That particular, as the wavelength is decreasing, there is a maximum radiation from the body, from the surface of the body. So as the temperature is increasing, that particular graph will shift to the left, but it is shifting to the right, my dear students, in this graph. So this is the wrong graph. This is the wrong graph. So it must shift towards the left. It must shift towards the left, my dear students. Okay. So let us see. Now, if you will see the solution, if you will see this, let us see. Now, so you can ask your doubt, my dear students, you can ask your doubt in the class itself. So this is the correct graph. If you will see this, so we know according to the Wien's displacement law what is there. So lambda max, and that is not lambda max, that is the lambda minimum wavelength, where maximum radiation is occurring, my dear students, where maximum radiation is occurring, multiply by that particular temperature is equal to nothing but some value which is equal to constant, my dear students, which is equal to constant. Okay, now you can see from here that as the lambda max is decreasing, as the lambda max is decreasing, the temperature is increasing, or vice versa is also true. As the temperature will increase, that lambda will decrease, that lambda will decrease. So my dear students, as you can see here, as the temperature is increasing, that there it is 3000 Kelvin, 4000 Kelvin, then 5000 Kelvin, the lambda is decreasing. The lambda is decreasing, or we can say the maximum radiation where it is occurring at that particular wavelength, that is decreasing, my dear students, where the maximum radiation is occurring. So that particular wavelength is decreasing. You can see from the graph. So I hope this question is clear to you right now. So now let us see. So if you will see, the peak is moving towards where? Towards the left. I have told you already. So this was the simple question for 2 marks, my dear students. This was a simple question for 2 marks. So let us move on to the next question. Let us see what will happen. Now, this is the shape factor question, and it is the easiest question I have seen. So many of you can easily reply. So please provide me the answer in the chat box. Anshul, Sohan, you can tell me the answer in the chat box. Okay, Sohan, you can also tell me the answer in the chat box. So let us see. A solid sphere, a solid sphere of one, that is the solid sphere they have given, one of radius r, which is having the radius r, is placed inside a hollow, closed hemispherical surface 2, which is having radius 4r. So what is the radius they have given? Let us see the solution, my dear students. I think you know now what is shape factor. Easily you can calculate all the, and usually you can do all the questions in the gate. So they are asking the simplest questions, my dear students. So they are asking the simplest questions, my dear students. So let us see. Now let us see. If you will see, they have given a sphere, which is a solid sphere they have given, and that solid sphere is placed inside what? A hemisphere, a hollow hemisphere. Okay, now what you have to calculate, you have to calculate that f21 means the radiation which is leaving surface 1 and reaching surface, leaving surface 2 and reaching surface 1. You have to calculate that particular radiation. Okay, now what will be the fraction of radiation which is leaving surface 2? What is the surface 2? So surface 2 is everywhere. So that is hemisphere. And if you will analyze this, it is something like this. It is something like this. So there will be a flat surface, and there will be a radiation which will be occurring from, that is coming out from this particular that particular hemisphere half surface. This will represent like a circle. Okay, this will represent like a circle. So some of the radiation will come out from here, and it will go to the one. Okay, and there is this another part from where that radiation is falling, that is radiation waves are coming from that particular and falling on the solid which is there inside the particular hemisphere. Okay, so like that there will be radiation heat exchange between these two surfaces. And what we want to calculate, my dear students, we have to calculate the shape factor, which is nothing but f21 he is asking, f21 he is asking, my dear students. So let us calculate it. So how you will do that? Tell me how you will do that. So Saurabh, you can tell me in the comment box. Okay, tell me the answer first. I hope you are solving all these questions, and you have already solved these questions, so you can give the answer in 1 minute. Anshul, you can also give me the answer in the comment box itself. So let us see this question. I'm trying to solve this. So अभी मैं क्वेश्चन ये सॉल्व करते हैं, कैसे करते हैं देखिए. यहाँ पे क्या है, अगर आप सरफेस को देखेंगे तो रेडियस क्या दिया हुआ उसने बेटा, उन्होंने सरफेस स्फीयर जो दिया हुआ है पहला वाला, दैट इज स्फीयर 1 दे हैव गिवन, व्हिच इज हैविंग रेडियस r. सो व्हाट इज द रेडियस ऑफ स्फीयर? सो लेट अस सी. सो दे हैव गिवन द रेडियस ऑफ स्फीयर. रेडियस ऑफ स्फीयर कितना दिया हुआ है बेटा? रेडियस ऑफ स्फीयर दे हैव गिवन r1 इज इक्वल टू r. ओके, r1 इज इक्वल टू r, बिकॉज डायमीटर कितना है? 2r है. So what will be the radius? That will be become on R1 will become equal to R only. So let us see what is the radius of hemisphere. So radius of hemisphere will be equal to hemisphere, that is equal to nothing but R2 will be equal to how much? R2 will be equal to how much? That will be equal to your 4R, because diameter is given how much? Diameter is given to be 8R, my dear students. Diameter is given to be 8R. So let us see. So can you calculate the area A1? Yes, you can easily calculate the area A1. So area A1 will be equal to nothing but how much? This will be equal to 4 pi R square. 4 pi R square. So this will become 4 pi R square, my dear students. So this will become 4 pi R square, my dear students. That is simple. Now, if you will see the that particular R2, what will be the area R2? Simple question they are asking. Simple question they are asking. That is for the hemisphere. This will be the some like some particular portion of this. So there will be some particular portion for this. So I'm taking that from like basic to advanced level. So don't worry. So this will be a circle, my dear students, which is having radius nothing but 4R. So what will be the area A2? Area A2 will be equal to nothing but area of that particular circle, which is equal to nothing but pi R square. What is the R for this R2? Pi R2 square, pi R2 square, pi R2 square plus the area of hemisphere. What will be the area of hemisphere? That will be nothing but half into 4 pi R2 square, R2 square. So let us put the value of R2. What this will become? Let us see. So this will become equal to something like, let us see what it will become. So there will be, this will become 4 pi, which is nothing but pi into 4 R square. Okay. Now half that 2 will go. So there will be only 2 pi. 2 pi into 4 pi R square, because R2 is equal to how much? That is 4R. Okay, R2 is 4R. So this particular value will become 3 pi into 4R square, and that will be your area A2. Let us talk about the shape factor now. Let us talk about the shape factor now. So my dear students, you can ask your doubts in the comment box. Viswanathan, Viswanathan, yes, tell me Viswanathan. Exchanger, not exchanger. Okay. Exchanger. Okay. What is your question? What is your question? I'm not getting you, Viswanathan. Tell me your question, please. If you are talking about the heat exchanger, we will cover soon the heat exchanger also, and we will finish that particular all the gate questions related to the heat exchanger in the upcoming videos. So don't worry. Just connect it to the Ekeeda application and YouTube channel. You will enjoy each and every subject and each and every topic, my dear students. Okay. Now let us see this question. So here there will be something like this area will become A2 will become this much. So I'm taking it slowly. Let us do it fast. Okay, let us do it. Now what will be the shape factor related to this? So if I will consider for surface 1, if I will see surface 1, so for surface 1, surface 1, if I will use the summation rule, my dear students, if I will use the summation rule. So what will be the summation rule? We know that for the particular surface, that summation rule says that what, that F, the radiation which is emitting from 1 and falling on 2, radiation which is emitting from 1 and falling on 1 itself, but the self view factor for the sphere will be 1, because this is what, this is the convex body. For the convex surface, the self view factor is always 0, my dear students. The self view factor. Anirudh Tari, yes. Anirudh, yes. Welcome to the class, beta. So, because that is the convex surface, my dear students. For the convex surface, what is your self view factor? That is equal to nothing but F11 will be equal to how much? That will become equal to 0 for the sphere 1, which is inside the hollow sphere. So plus F12, which is the which is nothing but the radiation which is coming out from surface 1 and falling on surface 2. Surface 2. So this will become nothing but which is coming out from 1 and falling on surface 2 will be equal to nothing but 1. Will be equal to nothing but 1. So there F12 will become beta. क्या बन जाएगा बेटा? ये F12 will be equal to 1. So now you have to calculate the value of F21, the shape factor, or we can say the configuration factor, that which is falling, that is which is coming out from the surface 2 and falling on 1, my dear students. So you have to calculate this F21, which is coming out from 2 and falling on 1, my dear students. So F21 you have to calculate. So let us use the reciprocity theorem. So according to reciprocity theorem, what we have, tell me the answer first. If you know, tell me the answer in the comment box. Reciprocity theorem, we know that A1 F12 is equal to A2 F21, my dear students. Simple. Anirudh, is that simple? Yes. So let us see. So A1, what is the value of A1 here? So A1 is nothing but equal to, A1 is nothing but equal to 4 pi r square. 4 pi r square. So this will become 4 pi r square, my dear students. What is the value of F12? You have calculated. That is equal to 1 is equal to nothing but A2. What is the value of A2? 3 pi 4 r square. 3 pi into 4 r square. So this will become how much? 16 r square. Very good. Multiply by f21. So what is the f21 value you have to calculate? So let us cancel each and every which can go. So this will become something like r square can also go, and 4 to 4. So 4 4s are this. So this will become 12. So this will become nothing but 1 is equal to 12 into f21. F21. So my dear students, you can easily see that F21, that is the shape factor related to which is leaving surface 1 and falling on leaving surface 2 and falling on 1 is equal to nothing but 1 upon 12. So 1 upon 12 will be the right answer, my dear students. So 1 upon 12 will be the right answer. So what is the right answer, my dear students? That is answer A. So A will be the correct answer. So A will be the correct answer. Anirudh, Vishwanath, and Anshul, you can ask your doubt here, beta. If you have any doubt in heat exchangers, like in radiation or heat exchanger, or any doubt you can ask. So don't worry. So let us see. Let us see. So is that question clear, my dear students? बेटा सभी को ये क्वेश्चन क्लियर है? Is that question clear to everyone? सभी को क्लियर है? Yes, yes, I am using Hindi. Don't worry. I am using Hindi. Don't worry. So now let us see the next question. So now let us see the next question. So this is the simple question they are asking. That is for 2 marks, my dear student. That is for 2 marks they are asking. This is the simplest question they are asking. So tell me the answer first. Rohan, Anirudh, you can tell me the answer. Just tell me the answer. What will be the answer for this? So if you will see this question, simply they are what they are asking. Let us see. So here the emissive power of a black body is P. So what is the emissive power of a black body? P. If the absolute temperature is doubled, the emissive power of the body will become equal to how much they are asking. The emissive power of the body will become how much they are asking. So you know what is the emissive power, my dear students. So let us see the solution. So if you will see this solution, what is there? If you will see the solution, what is there? So the emissive power of any black body is directly proportional to the temperature to the power 4. Simple concept. Asking for 2 marks in the gate. Very simple, my dear students. So if emissive power of a black body is given to be P, so they have given emissive power to be P. So P will be directly proportional to T to the power 4. Simple. Okay. Now, if temperature is doubled, so if temperature will be doubled, let us say that is P is equal to nothing but T1 to the power 4. So if you will double the temperature, if you will increase the temperature 2 times, if we increase the temperature 2 times, the temperature 2 times, so they are increasing the temperature 2 times, 2 times. So what will be the final temperature? So the final temperature T2 will become equal to nothing but twice of T1, my dear students. Twice of T1. Yes or no? Yes. So let us put this value. So if you are doubling the temperature, if you are increasing the temperature 2 times, so what will be the your emissive power? That will become equal to how much? Let us see. So the emissive power P2 will be equal to nothing but, so let us take it P1 only. So P2 is equal to nothing but, that is nothing but directly proportional to what? T1 to the power 4. So that will become T to the power 4. So let us put the value of T1. So this will become equal to that T2 is equal to or we can directly take P2 is directly proportional to T2 means twice or T1 to the power 4, twice of T1 to the power 4. That implies this will become equal to T2 is equal to 16 T1 to the power 4. So what is T1 to the power 4? That is nothing but equal to P1. That is from the equation 1, my dear students. So this value will become equal to, that is P2 is equal to 16 times of P1. And what is the value of P1? That is itself P1, P only. That is itself P only. So P2 will become equal to 16P. 16P, my dear students. So that will be your particular answer. And they are asking these kind of simple questions in GATE 2017 for 2 marks. Yes or no? For 2 marks, my dear students. So let us see the next question. अगले क्वेश्चन पे चलते हैं बेटा. बताएं अगर किसी को कोई भी डाउट है तो यू कैन टेल मी इन द कमेंट बॉक्स. You can tell me in the comment box itself. So let us see. Let us see. So this is your question, and this is the simplest question, I think. So you can do that. So tell me the answer. Tell me the answer. Saurabh, you can tell me the answer. Tell me the answer. So here I'm reading the question. Let us see. So what they have given is, let us see. So a spectral distribution of radiation from a black body at T1 is equal to 300 Kelvin. Okay. सो फर्स्ट टाइम लाइक टेकिंग द सिंपल न्यूमेरिकल्स. तो जितने भी सिंपल न्यूमेरिकल्स हैं बेटा उनसे स्टार्ट कर रहे हैं अपन, और सिंपल न्यूमेरिकल्स से फिर धीरे धीरे हम लेवल बढ़ा रहे हैं सो दैट कि सबको समझ में आए. ठीक है, शुरू से एकदम स्टार्टिंग से सारी चीजें क्लियर होते चले जाएं. तो पहले जो बेसिक बेसिक चीजें हैं मैं उनको लेके चल रहा हूँ अभी क्लास में, सो दैट ईच एंड एवरी पर्सन विल अंडरस्टैंड. फिर जो थोड़ा सा हम लेवल अप करेंगे, जो हमारे क्वेश्चन पढ़ रहे हैं धीरे धीरे उनका लेवल अप होते जा रहा है और इजिली आपको समझ में आएगा. सो डोंट वरी. सो अनिरुद्ध and Saurabh, you can tell me what will be the answer? Let us see. The spectral distribution of radiation from a black body at temperature T1 is equal to 300 Kelvin has a maximum at wavelength lambda max. चलिए कोई प्रॉब्लम नहीं है. What he is saying? The spectral distribution. मैं क्वेश्चन रीड कर रहा हूँ अभी, ध्यान से सुनिए जरा, ध्यान दीजिए थोड़ा क्लास में. The spectral distribution of radiation from a black body. So he have given the black body already, my dear students. So he have given the black body at temperature T1, which is nothing but equal to 300 Kelvin, has a maximum at wavelength lambda max, has a maximum emissive power at the wavelength lambda max. The body cools down to a temperature T2. Now, पहले body T1 पे थी, the body was at particular temperature T1, then it is cooling down to temperature T2. If the wavelength corresponding to the maximum of the spectral distribution at T2 is 1.2 times of the original wavelength lambda max. So wavelength is increasing how much? So wavelength is have been increased to 1.2 times of the original wavelength of the previous wavelengths, my dear students. Then the temperature T2 in Kelvin he is asking. So round off to the nearest integer. So let us see this question. So he is talking about the like how you will approach the question. कैसे? He is talking about the maximum radiation occurring. So maximum radiation or maximum radiation at particular wavelength he is asking. So what we can use here? So we can use the Wales displacement law. So let us see the solution, my dear students. So solution for this particular 2-mark question, they have asked it in where? Set to 2020 for 2 marks. Simple question they are asking. Okay, very simple questions they are asking. So let us see. So if you will see the solution, so what is according to Wayne's displacement law, what you have? According to Wayne's displacement law, so what is Wayne's displacement law, my dear students? So we know the radiation at the wavelength at where maximum radiation is occurring multiplied by some particular temperature T is equal to 2900 micrometer, or we can take it to the constant. Okay, you can take it like constant, no problem. So in this case, so can we take that lambda 1 or lambda max 1 into temperature T1 is equal to lambda max 2 and temperature T2, my dear students, and temperature T2, no problem, I hope. Temperature T2. So what he have given, that wavelength have changed to 1.2 times of the original wavelength. Now he is asking T2. He is asking T2 because T1 he has already given. So what is the value of T1? He have given T1 he has given to be 300 Kelvin. Okay, no problem. अभी तक कोई problem नहीं है किसी को. Okay बेटा. So yes, Rahul, tell me. Rahul. So 300 Kelvin. Okay, no problem. So let us put all values in this particular equation. Let us put all the values in this equation. Okay. So what we will have, let us see. So lambda max 1 multiplied by temperature T1. What is the temperature T1? That is nothing but 3000 Kelvin. 3000 Kelvin is equal to lambda max 2, which is nothing but equal to 1.2 times lambda max 1. Lambda max 1. So this will become equal to how much? Lambda max 1. So 1.2 times of lambda max 1. Okay. Multiply by temperature T2. Multiply by temperature T2. So lambda max 1 and lambda max 1 will go. So what you will left with? You will left with only 3000 Kelvin divided by 1.2. So this value will become equal to how much? 12, and this will become something like 2500 Kelvin. 2500 Kelvin, my dear students. And I hope this question is very simple, you can do. And this question they are asking for 2 marks in the gate. You can easily understood this. So for 2 marks they are asking. And I hope everyone is getting this concept. So is that clear to everyone? So formula based question he is asking, beta. Formula based question he is asking, okay? So let us move on to the next question. Next question पे चले. Everyone in the class. Okay. Very good. Anirudh. Anirudh Tari. Yes, beta, you can ask your doubt here, or you can visit the Ekeeda web YouTube channel, and you can enjoy each and every single topic there. Okay. So let us see. Let us see. So if we will talk about this particular question, so this is some nice question we are having in the gate 2019 for set 2 for 2 marks. Okay. So let us see this question. So this question is related to your what? This question is related to your shape factor. Okay. So let us see. So three sets of parallel plates LM. So parallel plates L and M. So two plates are there, my dear students. This is plate L. This is plate M. Okay. Now three sets of parallel plates LM, NR, NR, and PQ. That is your PQ are given in figures 1, 2, 3. Given in figures 1, 2, and 3, my dear students. The view factor Fij is defined as, अगर वो view factor की बात करें, if they will talk about the view factor, so how they are defining the view factor, that is the view factor Fij is defined as the fraction of radiation leaving plate I. Okay. So अगर I और J की बात कर रहे हैं बेटा, तो कैसे हो रहा है? So view factor means if radiation leaving plate I and falling on J, leaving plate I, that is intercepted by plate J. Assume that the values of FLM and FNR 0.8 and 0.4 respectively. Okay. So let us see this question. Let us see the solution, my dear students. So if you will see that they are saying that Fij is defined to be how they are defining Fij, the radiation which is leaving surface I. If this is the plate I and this is the plate J, so this will be something like that I living and falling on J or intercepted by the J. So Fij. So like that he is defining all the parameters or all the particular shape factors. So FLM is how what? FLM is nothing but which is leaving one and falling on two or intercepted by two. Yes or no? Now, similarly, FNR is nothing but which is leaving surface one N and falling on surface R or plate R. Okay. So he have given the values of FLM and FNR. So let us see the solution. So if you will see the solution for particular this particular situation, so let us consider Q is not seen the in this Q question is visible. Okay, question is not seen. So I'm reading, my dear students. So three, like they have given the three plates. Okay, three plates they have given: LM, NR, and PQ. Okay, so let us see this. So LM is this plate. LM is like this plate, my dear students. चलिए मैं रिपीट कर देता हूँ क्वेश्चन, कोई प्रॉब्लम नहीं है बेटा. So LM is this particular plate. If this is plate L and this is plate M, okay, this is plate L and this is plate M. Now second plate is your NR. ये plate अगर N है तो this is your R plate. This is plate N, this is plate R. No problem. ठीक है. And they have given to be like this plate is of having like 1 meter distance, and also in between there is a 1 meter distance. No problem. Okay. So I'm just telling you the question, just try to understand this. So this is the L plate they have given. So they have given this plate to be L, okay, and that plate second to be M. So this is 1 meter. This particular value is 1 meter. This particular value is also 1 meter, my dear students. Okay, this particular value is also 1 meter. I think there is no issue. No issue. Okay. Also, he have given the another plates like PQ. So this is plate P, this is plate Q. Again the same distance. This distance he have given to be how much? This distance he have given to be 1 meter. No problem. Okay. 1 meter he has given. And the value of P, like this distance he have given to be like how much? 1 meter. No problem. Similarly, this distance he have given to be 1 meter. So what he is asking? Sorry. So the value of FLM, what is the meaning of FLM? The radiation which is leaving plate L and falling on M, he has given to be how much? 0.8. Okay, 0.8. So the value of FLM, so the radiation which is leaving surface L or plate L which is falling on plate M is given to be how much? 0.8 beta. Okay. Now, and also he have given some value of FNR, that is the U factor for FNR or shape factor for NR, which is leaving surface plate 1 N and falling on surface R. So NR का मीनिंग क्या हुआ बेटा? जो N से निकल रहा है रेडिएशन और R पे फॉल हो रहा है. ठीक है. So this is he have given to be how much? 0.4. Okay. Now you have to calculate the shape factor for FPQ. So you have to calculate the shape factor for this particular third plate, that is P, the radiation which is coming out from P and falling on Q. So calculate the shape factor for FPQ. Okay, he is asking. So how you will do this question? Okay, Anil Tari, very good, very good. Savyanchi Singh. Okay, Savyanchi, you can ask me any question or doubt here. You can forward this lecture to your colleagues or mechanical students, my dear student. So let us see बेटा, यहाँ पे क्या होगा? FPQ क्या होगा यहाँ पे? फिर FPQ कैसे निकालोगे? How you will calculate the value of FPQ? So let us assume, let us do this question. This is the very easy question, very easy question. So just you have to use the little bit of concept and you can easily do this question in 1 or 2 minutes, my dear students. You can easily achieve 2 marks in GATE. Okay, 2 marks in GATE. So let us see. Let us assume this surface to be 1. Okay, let us assume this surface to be 1. Okay, assume this surface to be 2, this to be 3, and this to be 5. So what I'm assuming is, or this to be 4. Okay, what I'm assuming is that particular plate is I'm representing by 1. That area of that particular or that particular plate I'm representing by 1, and this particular plate I'm representing by 2. This particular plate I'm representing by 3, and this particular plate I'm representing by 4. Okay, no issue. Now, if you will see that particular FLM, LM, so can you do that? Like how? The radiation which is leaving plate L and falling on M, falling on M, but M have 3 parts. Now I have done, or I have converted M plate into 3 equal parts of 1 meter each. So this will become what? So I can easily say the radiation which is leaving surface 1 and falling on 2, the radiation which is leaving surface 1 and falling on 3, the radiation which is leaving surface 1 and falling on 4. So this will be represented by, if you will use the summation rule, beta summation rule use करने के बाद क्या होगा, that F11, the radiation which is leaving surface 1 and falling on 1 itself, self Q factor, because that is a flat surface. ये surface कैसा दिया हुआ बेटा, ये दिया हुआ flat, and for flat surface the F11 means the self Q factor will be 0. Yes or no? So you can write like F11 plus F12 plus F13 plus F14 is equal to nothing but FLM, which is given to be how much? FLM, which is given to be how much? 0.8. 0.8, my dear students. 0.8. Okay. So this will become how much? So F11 is already 0 because self view factor is given equal to 0 for that. So F12 plus F13 plus F14. F14. So this is the surface 2, my dear students, 3, and this is the surface 4. Okay, this is the surface 4. Now let us see. Let us see. So this is they are asking for PQ. They are asking for PQ, my dear students. This is also like 1 meter like this. 1 meter like this. Okay. Now, so let us see this question. So F14 is given to be how much? Can you calculate the value of F13? Yes. What is the value of F13 means? That F13 is equivalent to nothing but FNR. FNR. How? Because this is plate 1 and this is plate 3, my dear students. This is plate 1 and this is plate 3. Okay. This is particular plate 3. So you can easily see this. So what will happen? So FNR they have already given. How much they have given to be FNR? 0.4. So this is equivalent to how much? FNR. So let us put this value in this equation. Like first equation, what you will have. So if you will put the value of F13, so you will have F13, which is equal to nothing but how much they have given? 0.4 plus F12 plus F14 is equal to 0.8. So let us put the value of F13 here. So what is the value of F13 beta? That is 0.4 plus. So if you will see these both plates, these are symmetric. So plate 1 and 3, 1 and 2, and 1 and 4 are symmetric. 1 meter, 1 meter, 1, and equal angle, equal distance. Okay. So these are symmetric. So you can write this to be twice of F12 is equal to 0.8. 0.8. So you can calculate easily the value of F12. So what will be the value of twice of F12 will become? So I will take this part to this side. So this will become 0.8 minus 0.4. So this will become 0.4. So if you will calculate the value of F12, the value of F12 will become equal to how much? This will become equal to 0.2, my dear students. Okay. So value of F12, or you can directly see the value of F12, the radiation which is coming out from 1 and falling on 2 is equal to F12 is equal to how much? 0.2. But you have to calculate the value of FPQ. FPQ. So यहाँ पे देखें बेटा, this is surface 1, this is surface 1, this is surface 3, this is surface 3, and this is surface 4, this is surface 4. So now you have to calculate FPQ. So FPQ is equal to nothing but FPQ is बराबर किसके बराबर हो जाएगा बेटा FPQ? That is nothing but F of the shape factor for F13 plus shape factor for F14. F14. So you know the value of F13 already. What is the value of F13? They have given, that is 0.4. So let us put this value 0.4 plus what is the value of F14? So F12 is equivalent to nothing but F14. ठीक है? F12 कितना आ रहा है बेटा? F0.2, and this is coming to also, this is equivalent to nothing but F14. So let us put the value of F14. So that F14 value is 0. How much? 0.2. So the value of FPQ will become equal to F of PQ will become equal to how much? 0.6. And this will be the answer for this particular question. I hope you understood this question. Is that clear to everyone? Is that clear to everyone? Vishwanathan? Anshul Panjala? Anshul Panjala, is that clear? So let us move on to the next question, my dear students. Let us see the next question of GATE. That question is like of GATE 2019, and they have asked for 2 marks. This is the simplest one. So if you know the concept in GATE and fundamental in GATE, you can do easily each and every question. Okay, each and every question you can do easily. So please tell me in the chat box, everyone. Rajput, Sohan, Anirudh. Please tell me in the chat box your doubts and your questions you can ask. Anshul, yes, beta, are you there? So forward this video to everyone so that each and every person will understand, each and every student will have the benefit of this. So सभी को शेयर करिए बेटा, सभी को बताइए, सभी को शेयर करिए so that each and everyone can understand the concept. So let us see the next question. Let us see the next question. So if you will see the next question, what they have given, let us see. Let us see what they have given. So let us see the question. Is that particular available? Is that question available, beta? Let us see. The total emissive power of a surface is given to be 500 watt per meter square at a temperature T1 and 1200 watt per meter square at a temperature T2. ठीक है, तो डायरेक्टली मैं बेटा सॉल्व कर रहा हूँ क्वेश्चंस, जल्दी जल्दी हम कर रहे हैं, ठीक है, जल्दी जल्दी क्वेश्चंस कर रहे हैं, तो इसी तरीके से आपको क्वेश्चंस अटेम्प्ट करने हैं और बहुत ही सिंपल क्वेश्चंस है। अगर आपको फॉर्मूला और कंसेप्ट आपको थोड़ा सा भी पता है तो आप ये क्वेश्चन कर सकते हो। ओके, इफ यू नो द फॉर्मूला एंड कंसेप्ट यू कैन इजीली अटेम्प्ट द गेट क्वेश्चन एंड यू कैन सी, आप देख सकते हैं कि बहुत ही सिंपल सिंपल क्वेश्चंस, बिल्कुल सिंपल सिंपल जो आपके कंसेप्ट है उन पे रेडिएशन में 2 मार्क्स के क्वेश्चन पे पूछ रहे हैं डायरेक्टली। ओके, और अभी मैंने 17 और 19 का पहले भी हमने किया है क्वेश्चन, आप देख चुके हैं बेटा, ठीक है। सो आप जो भी नए बच्चे कनेक्ट हो रहे हैं प्लीज बेटा अपना जो है कमेंट बॉक्स में यस सर यू कैन आस्क योर डाउट, कमेंट बॉक्स में आप अपना डाउट पूछ सकते हैं। सो लेट अस सी द टोटल इमिसिव पावर ऑफ ए सरफेस इज 500 वाट पर मीटर स्क्वायर, लेट अस सी एट ए टेम्परेचर T1. सो लेट अस सी द सॉल्यूशन फॉर दिस, लेट अस सी द सॉल्यूशन फॉर दिस। सो व्हाट ही हैव गिवन, टोटल इमिसिव पावर की बात कर रहे हैं बेटा, है टोटल इमिसिव पावर की बात कर रहे हैं, वो भी पर यूनिट एरिया बात कर रहे हैं। ओके, so they are asking per unit area. So what they have given, let us say the total emissive power, they have given the total emissive power, total emissive power of black body, okay, of black body per unit area. So you can see they have given per unit area, watt per meter square, black body per unit area. So how you will calculate the total emissive power per unit area, my dear students? Is nothing but equal to E black body per unit area, means that is particular A. So this will be given by watt per meter square, and this will be equal to nothing but sigma T1 to the power 4. Sigma T1 to the power 4, my dear students. Is that clear? So let us see now. So EB1 he have given. So what is EB1 he have given? EB1 he have given to be how much? EB1 is equal to 500 watt per meter square. Very good. 500 watt per meter square. Very good. So this can be like, let us take it one, question one, at temperature T1. At temperature T1 he is asking, so you can directly also write like EB1 is equal to sigma T1 to the power 4. T1 to the power 4. Similarly, you can write EB2 also. EB2 also. EB2 is equal to sigma T to the power 4. Simple. Okay. Simple questions he is asking. Let us see. Now, what is the value of EB2 he have given? The emissive power, total emissive power of a black body per unit area. What he have given to be? 1200 watt per meter square. कितना दिया हुआ है बेटा? 1200 watt per meter square. Per meter square. So let us put all the values. So if you will put all the values, this value in this equation, this value in this equation, what you will have? Let us see. Let us see. So at temperature T2, where the temperatures are in Kelvin, assuming the emissivity of the surface to be constant, the ratio of temperatures T1 and T2 is. So he is asking about the ratio of temperatures T1 and T2. He is asking about the T1 divided by T2 ratio he is asking. So can you tell me this? This is the simple question. So for this, what you have to do? You have to do one thing, that is nothing but EB1 by EB2 is nothing but equal to sigma T1 to the power 4 divided by sigma T to the power 4. Okay, sigma T to the power 4, where sigma will be cancelled out. Let us put the value of EB1 and EB2. What is the value of EB1? This is nothing but 500 watt per meter square. Units are the same. So there is no problem. So put this value 1200. Okay, so this and this will go. So you will directly have that T1 divided by T2 the power 4 is nothing but equal to 5 divided by 12. No problem. So let us take this part. So what he is asking, T1 by T2. So T1 by T2 will become equal to 5 बटे 12 to the power 1 by 4. So this value will become equal to how much? Let us see. This value will become how much? Let us see. कितना आएगा बेटा, बताएं जल्दी. कैलकुलेटर यूज करें बेटा, बताएं मुझे कितना आएगा, आंसर कितना आएगा. Rohan, Ritik, you can tell me. Let us see. So this will be 5 by 4. This will be equal to 0.83. 0.803 beta. Okay. 0.803. So the answer will be C. Answer will be C, my dear students. Is that okay? Answer will be C. बेटा आप अपने यहाँ पे डाउट्स पूछ सकते हैं. You can ask your doubts. Just tell me. So let us see the next question बेटा. नेक्स्ट क्वेश्चन देखिए. नेक्स्ट क्वेश्चन देखिए. Simple one. Okay. GATE 2014 set 3 2 marks. Okay. Let us see this question. A solid sphere of radius R1 which is equal to 20 millimeter is placed concentrically inside a hollow sphere. Okay. So there are two spheres. One is solid. So outer one they have given to be how much? Or hollow. Hollow. And the inner one they have given to be like what? Solid. Solid. Okay. So a solid sphere of radius R1 is equal to 20 millimeter is placed concentrically inside a hollow sphere of radius R2 which is having the radius 30 millimeter as shown in the figure. The view factor F21 for the radiation heat transfer is. So this is the surface 2 beta. This is surface 2. Okay. This is the surface 2. So radiation which is leaving surface 2 and falling on 1 is asking F21. F21 he is asking. So tell me the answer in the chat box. Tell me the answer in the chat box. Let us see. So can you calculate the area beta? Area मैं solution यहीं पे करते हैं. अभी there is a lot of space available. So let us see the solution. So what is R1? R1 is how much? 20 millimeter. Okay. 20 millimeter. What is the value of R2? 30 millimeter. No problem. Okay. Now what he is asking? F21 he is asking. F21. So how you can calculate F21? So let us use the summation rule. Let us use the summation rule. Let us use the summation rule beta. Summation rule use कर सकते हैं. So what is summation rule? Let us use the summation rule. So this is equal to how much? That for surface 1, फॉर सरफेस 1। सो अगर आप सरफेस 1 को देखेंगे तो क्या हो जाएगा बेटा, दैट विल बी F11 plus F12 is equal to how much? 1. Okay. So F11, but this is a convex surface. This is a convex surface बेटा. Convex surface के लिए F11 means selfie factor कितना हो जाएगा? 0 हो जाएगा, ठीक है. So from here you can directly see that F12 will be equal to how much? 1 beta. Okay. F12 will be equal to 1. Now let us calculate F21. So F21 कैसे आएगा बेटा? So what is F21? So you can directly see F21. So if you will use the reciprocity theorem, what is there? Let us see. F1 2 into A1 is equal to A2 F21, right? A2 into F21, right? So let us see. So F12 you have calculated already, which is equal to 1. So 1 multiplied by what is the area A1? Area A1, because this is a sphere. So sphere they have already given. So this will become how much? This will become 4 pi R1 square is equal to nothing but A2, which is nothing but 4 pi R2 square. So outer one is also a hollow sphere, okay? Multiply by F of 21, you have to calculate. So 4 pi and 4 pi will go. So you will be left with, if you will write here, this will become F21 is equal to R1 square divided by R2 square. R1 square divided by R2 square. And this will become, what is the value of R1? That is 20 millimeter, my dear students. So I'm not changing the units, because if you will take both in the same units, there will be no issue. So what is it? What is this? This will be 30 square. So this will become something like 400 divided by 900. Okay, or directly you can also pencil here. So this will become 4 by 9. So the answer for this particular question will be 4 by 9. So the value of F21 will be equal to 4 by 9. So this will be the answer, my dear students. I hope this is clear. Is that clear to everyone? Is that clear to everyone? So Rakesh, you can ask me. Yes. Tell me your doubt, beta. बताते रहिए, डाउट बताते रहिए सभी. सो इस तरीके से अब 2 मार्क्स का क्वेश्चन है बेटा. ये 2014 में पूछा गया है, 2 मार्क्स का क्वेश्चन है. बहुत ही सिंपल है, ठीक है. आपको कंसेप्ट पता है दोनों. कौन से? रेसिप्रोसिटी थ्योरम आपको यूज करना है, समेशन रूल आपको यूज करना है. शिफ्ट फैक्टर के क्वेश्चंस आते हैं हमेशा. गेट में एक क्वेश्चन आता है शिफ्ट फैक्टर का 2 मार्क्स का, हीट एंड मास ट्रांसफर से. लेकिन ज्यादातर बच्चे क्या करते हैं कि दूसरा सिलेबस पढ़ते रह जाते हैं और ये सिंपल चीजें नहीं करते हैं. तो सबसे पहले यदि अभी भी आप स्टार्ट करेंगे तो आई विल हैव ऑलरेडी टोल्ड इन द लाइक प्रीवियस चैप्टर्स और प्रीवियस लाइव लेक्चर्स ऑल्सो, और जो लेक्चर्स आपके पढ़े हुए हैं, लेक्चर जो अपलोडेड हैं ऑलरेडी हमारे Ekeeda GATE ESC वाले पोर्टल पे, जो मैकेनिकल का पोर्टल है, वहाँ पे यूट्यूब पे आपके अवेलेबल हैं. वहाँ पे भी आपको मैं आपकी पूरी कंप्लीट वीडियोज में बता रहा हूँ कि कौन कौन से टॉपिक आप पढ़ के इसलिए यू कैन गेन अप्रोक्सीमेटली 5 मार्क्स itself in your particular gate paper. Okay, so let us see, and I hope that everyone is enjoying this particular class. So I will stop here, and we will discuss like different vectors in the next chapter, my dear students, in the next lecture. So I hope you have enjoyed the class, and thank you so much. Okay, thank you so much everyone. Thanks a lot. Okay, thank you, no time. Thank you, DM. Thank you so much, DM. Thanks a lot. So every Sunday there is a class. You can take my live classes in the like on the YouTube portal at 5 p.m. every Sunday. We are having heat and mass transfer live classes. So thank you, my dear students, and have a good time. Thank you so much.